Welcome to Chapter 9B. In this particular lesson, Lesson 1A, we are going to look at turning functions into power series. I'll pull up here the definition of a power series, and you should be familiar with this from Chapter 9A. Just take a moment to look at it to see that a power series is a function of x, and it is preceded by these terms C0, C1, etc., etc. The top one is centered at 0, and the bottom one is centered at A. Now, there's going to be 5 things that we do in this lesson to turn a function into a power series. So, let's see. Number 1, what we're going to do is we are going to recognize the function as the sum of a geometric infinite series. Number 2, I always love number 2, we are going to what's called raw construct. Number 3, we are going to memorize. Now, the raw construction portion will help us to construct those from which we will then memorize. Then number 4, what we will do is we will substitute into ones that we have memorized. Finally, number 5, we will manipulate known series, ones that we have memorized. So we memorize them, and then we will manipulate some of them. By manipulate, I mean derivative or integral. Okay, so in the first type, we're going to see that f of x equals, pardon me, getting used to this pen, 1 over 1 minus x. So this should be a review to you. And you would recognize this as geometric, where the first term is 1, and the common ratio is x. And that here, this quantity here, is the sum of a geometric. So if we write out the terms, it would be 1 plus x squared plus dot 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 plus x to the n plus dot dot dot, which equals the sum from 0 to infinity of x to the n. Now this is a power series, and it will converge to this function, but of course only if the common ratio in absolute value is less than 1, which creates the interval of convergence, -1 to 1. Alright, so taking a look at the next one, we'll call this one g of x, and this is 1 over 1 minus 2x. Again, this can be geometric. Let's take a look at the terms. 1 plus 2x plus 4x squared plus dot 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 plus the quantity 2x to the power of n plus dot dot dot. And of course, that is the series from 0 to infinity of 2x to the power of n. It is geometric, where the first term is 1 and the common ratio is 2x. And this, of course, will converge for the absolute value of 2x less than 1, which will lead us to -1/2 is less than x is less than 1/2, the interval of convergence. So these go on and on and on. I'll do a couple more here. So h of x equals 1 over 1 plus x. The difference here is that we will have an alternating series. So the first term is 1, the second term is -x, plus x squared minus x to the third plus dot 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 plus. Now we'll write this as the alternating, strictly alternating business. With that, x to the n plus dot dot dot, and that series will converge for its common ratio, and its common ratio is equal to negative x, which still leads to the interval of convergence. All of this is review. Let's look at one just a little bit different. Let's say, I don't know, p of x. And p of x is going to be 1 over 1 plus x squared. Okay, so let's take a look at these terms. It's going to be 1 minus quantity x squared plus the quantity of x squared squared minus quantity of x squared cubed plus dot dot dot. The nth term here, we see that it's strictly alternating, and it's going to be x to the second power to the n power plus dot dot dot, and that will be simplified to negative 1 to the n x to the 2n power, of course, from 0 to infinity. Now this interval of convergence will be where the absolute value of x squared, either negative x squared, will be less than 1, and that of course will also lead us to negative 1 is less than x is less than 1. You will notice that all of these have a center at 0. If I could just show you here, I can tell it has a center of 0, a center of 0. I didn't write the inequality here, but a center of 0, center of 0. But not all the radius are equal to 1, the radius of convergence. Here the radius is 1. Here the radius, when we divide out the 2, is going to be a half. So just interesting to note. Okay, so one more function, a little bit more challenging. This one is going to be 1 over 4 minus x. So this doesn't quite look like the sum of a geometric, but I'm going to manipulate this to be 1 over 1 minus the quantity x minus 3. A little sloppy, that's a 3. Now it looks geometric, where the first term is equal to 1, and the common ratio is x minus 3. Okay, so this will converge for the absolute value of x minus 3 is less than 1. We see here the center of the radius of convergence is 3, and the radius is 1. When we simplify this, we have from 2 is less than x is less than 4 as our interval of convergence. Now, dot dot dot, if we write out the terms, this is going to be the sum from 0 to infinity of x minus 3 to the power of n. All right, and that's where I'm going to stop part A. Stopping part A at really the review, where we look at a function, recognize it as the sum of a geometric, and find its interval of convergence and write the power series. So what is the answer here? Well, this is the answer here, because we have expressed f of x as an infinite series, a power series. So that's going to be the end of part A. Really just the tip of the iceberg. All the other parts, B, C, and who knows, D, E, and F, will be more the meat of the lesson.